Problem says write the following as a composition of two or more non-identity functions. So in these problems, we have to see how one function is plugged into another. And sometimes it takes a little creativity to imagine that. When I look at the expression square root of x plus 3, I see a couple of things happening. In the one case, we're adding 3 to an input, so that's one type of function or one type of operation that's occurring. And I also see that we're taking a square root of a thing. And so it is possible that this could be thought of as a composition of functions. What I'll do is I'll draw two machines representing the two functions. The first function could simply be adding 3 to an input. And so this would represent the yellow in my expression. So if you put x in on the left, what you get out is x plus 3. But then, according to order of operations, after we do the addition of 3, there's going to be a square root taken. And so that could be thought of as another function machine doing a square root on an input. This machine could be called g of x, and it's going to be taking a square root of an input. But when we write function notation, we let the input be x. And so this function would be called g of x equals square root of x. So if you put x in on the left, then what comes out is square root of x. But we're going to put in x plus 3 as an input. So then what comes out is the square root of x plus 3, which is what we have in our original problem. So this is the answer to the question. If f of x is x plus 3 and g of x is the square root of x, then if we were to compose these and write g of f of x, that is the same as writing this, where f of x becomes the input to g of x. And since f of x is x plus 3, this would simplify to g of x plus 3. And so all we have to do is plug the x plus 3 into here. So that we get the square root of the input, x plus 3. And there I just verified that this expression can be written as a composition of two non-identity functions, f of x and g of x.